Hey friends, and welcome to our chapter 1 review. There's 9 sections, so this is going to take a little while, so hope your writing hand is warmed up. So section 1 was on rates. This is just the beginning of it all. Okay, so rates are just fractions that compare to different types of numbers. So, beats per minute or miles per hour or any of those things. And then we have a unit rate, which is a fraction comparing two different types of numbers, but with a 1 in the denominator or bottom. So we're comparing some number to one of something else. Okay, to make a unit rate, do the division. Okay, and a lot of where we use unit rates is calculating the best value. Best value means the lowest unit rate. And so, I don't know what we're buying here. Let's see. Applesauce cups. Sure, or squeezies. Anyway, so a pack of 6 squeezies is $3.79. A pack of 9 squeezies is $4.50. And a pack of 12 squeezies is $6.89. And usually the question is, what's the best value? Which means which one has the lowest unit rate. And so we have to do the division. So $3.79 divided by 6 is 0.63 cents per squeezie. And this one turns out to be 50 cents per squeezie. And this one turns out to be 0.57. So the 9 squeezies for $4.50 is the best value or the lowest unit rate. Okay, so that was section 1. Whew. Section 2. This was complex fractions. And this was just reminding us that complex fractions are vertical fraction division. So, for example, 2/4 over 3/8. And so really this means we're just going to change flip. We can do it from here if you want, or we can just rewrite it as our regular fraction division. So we can rewrite it 2/4 divided by 3/8. Those mean exactly the same thing. Then we remember our keep change flip. So 2/4 times 8/3. That's multiplying by the reciprocal. And I'm going to a little pre-reduce because 4 goes into 8 2 times. And then 2 times 2 is 4/3, or if you want to change it, 1 1/3. I would accept either. All right, so that was the entirety of section 2. Just remember, if you have fractions in fractions, it means division. Moving right along, section 3. Dimensional analysis. This was our converting units. And I will hopefully make sure you guys know or are aware of the rates that you need for converting something. So I'm trying to look at this practice problem that I had before. So we've got a situation where we are going 22 miles per hour, so in 1 hour. And we want to change that to feet per second. Okay, so that means we need to change miles to feet and hours to seconds. So I'm going to set up my picket fence. Remember on this, we want to have our units opposite so they'll cancel out with this multiplying. It's different than cross multiplying. So first let's change the miles to feet. There are 5,280 feet in 1 mile. I have miles on top, so I'm going to put the 1 mile on the bottom, 5,280 feet on the top. And the miles cancel out, and I'm at feet, which is where I want it to be. So now I just need to change my hours to seconds. So in 1 hour, we already have hours in the bottom, so I'm going to put 1 hour on the top here, and that's 60 minutes. Okay, so the hours cancel out. And now I need to change minutes to seconds. So there are 60 in 1 minute. There are 60 seconds. Okay, minutes cancel out. We're left with seconds, which is what we wanted. Now remember, these are just fractions that we have that we're multiplying together. So we do 22 times 5,280 times 1 times 1, which doesn't change it. And that comes out to be 116,160 divided by 1 times 1 times 60, which is 3,600. And then if we do that division, we end up with 32.27 feet for every 1 second. That's a lot of feet in a second. Okay. The conversion on the test shouldn't be quite this complicated. But that's kind of the general idea. Alrighty, number 4, section 4. This is where we pop into being proportional. Proportional. And I like to define that as having a constant ratio or unit rate. So all of it, when we make them into fractions, all of the fractions reduce down to the same thing. Ooh, my pencil's noisy. Okay, so for instance, if we come back up here, these all reduced down. They did not reduce down to the same thing. Therefore, these fractions are not proportional. The prices of those squeezies are not proportional. Okay, then section 5, we talked about defining being proportional in a graph and proportional on a graph. And these are our 2 things. One has to be a straight line. And 2 has to go through the origin or the point 0, 0. Okay? All right, we are halfway through. Section 6, solving proportional relationships. Whew, there are a lot of big words in this chapter. This is the section where we learned how to cross multiply. I'll get there. Okay, so remember the steps to this. You multiply the 2 numbers diagonal. Diagonal. The 2 numbers that are diagonal to each other. I guess that needs an L. And then divide by remaining number. The number you haven't used yet. Okay, so let's practice that a couple of times. Again, there's an algebraic basis to it, but we're not going to talk about that till we get to our algebra chapter. So 7 over 11 equals x over 8. And we want to set up proportional relationships. So first, We're going to multiply the two numbers that are diagonal from each other. 7 times 8 is 56. And then we're going to divide that by the number we haven't used yet, which is 11. 56 divided by 11 is 5.1. Okay. Next, we're going to practice a couple more just because I want to make sure you're feeling super solid about this. Oh, that's something interesting we haven't talked about yet. I will throw this out there. You can actually check to see if two fractions are proportional by doing the full-on cross multiplying. So 21 over 28, and we want to verify that this is equal to 3/4. We can actually do the diagonal multiplying both ways. So if we do 21 times 4, turns out to be 84. And if we do 28 times 3, that actually also comes out to be 84. That verifies that those two fractions are actually proportional. So we can solve proportions or we can prove proportions using cross multiplying. One more practice. 5/6 equals 12 over x. And so 6 times 12 is 72. And then we divide by 5. And it comes out to be 14.4 or so. Okay? Cross multiplying, super useful. Remember my ganache recipe? If you need me to send it again, I totally will. Because ganache is yummy. All right, section 7. 7, 8, and 9, remember we were kind of calculating the same thing and calling it 3 different things. So 7 was, we called it the constant rate of change. So that's when we have a chart. So I think this is, back in the day we used to have to pay for our cell phone minutes because people thought we actually talked on the phone. We did actually talk on the phone. And minutes and the cost, how much each minute cost when we were talking on our phone. And so for 1,000 minutes, it would cost us $38. For 1,500 minutes, it would cost $53. For 2,000 minutes, it would cost $68. And 2,500 cost $83. So now the question is, what is the constant rate of change? Or is there a constant rate of change? Okay, so first we want to find the difference. What's the difference that gets us to each next level that we have here? So on top, it's a difference of 500 each time. Right? Okay, then on the bottom, it's if you can't figure it out by just looking at it, you can always take one and subtract the one before it. So 53 minus 38, which gives us 15. Now let's see if 68 minus 53 gets us the same thing, because we want to make sure. And look at that. And we'll do the last one, 83 minus 68. And so the change down here is 15 each time. Okay? So that's our change. Now, most of the time I've been having you put the bottom number up top, but in this case it's already written. Actually, no. Well, we can find out. We can actually put it 2 different ways and find out kind of 2 different things. If you want to know how many minutes we can get for $1, then we want to put the dollar in the bottom. So we have 500 minutes over $15. And if we do this division, 500 divided by 15, we'll get 33.3 minutes per dollar. But that feels a little bit weird, right? We don't usually say stuff per dollar. And so usually we would want to find out how much 1 minute costs, in which case we want to put the minutes in the bottom. So we'll put $15 over the 500 minutes. Okay, and then we'll do that division because we'll get a totally different number. If we do this division, it turns out that each minute costs about 3 cents. And really, that's the one that makes more sense, cost per minute. Is probably what I would have chosen, but it'll specify so you don't have to worry. It will say cost per minute or minute per dollar, and that way you know which one to do when. Okay, chapter 8 was on slope. Remember, slope is m. It's the change in y over the change in x, or it's the rise over the run. Yes, I make you guys write this down a whole lot of times because it's super important. Okay, so remember, if you have 2 points and you can use any one, or like that would be a point and that would be a point, that sort of thing. Or if you actually just have them written as an ordered pair, okay, to find the slope, we find the difference. So we're going to take the 2 y coordinates and do 11 minus 4, and that's over the 2 x coordinates, which would be 7 minus 2. 11 minus 4 is 7, and 7 minus 2 is 5. And we would just leave it right there as 7 over 5. And then remember, slope, if you see it in the equation, it's the number next to the x. And the last section, I'm trying to get through this super quick, hopefully it's enough of a review, is our direct variation. Direct variation, which really means the same thing as being proportional. But the one extra thing that you have to remember, okay, and remember, if it's asking same thing, constant of proportionality or constant of variability is the same thing as slope. It's just the number next to x, okay? With direct variation and being proportional, we have to make sure, especially when it's in a chart, that it also crosses through the point 0, 0. Okay, so we're gonna, I don't know where these numbers come from or a story that works for them, but I have a chart that has age, which is our x, and grade, which is our y. And I'm actually going to leave. The chart starts at age 9, and that puts us in 3rd grade. And if you're 11, you're in 5th grade. I'm guessing that's what this means. In 13, you turn 13 in 7th grade. You turn 11 in 5th grade. That's what's happening right now, okay? You turn 15 in 9th grade, and you turn 17 in 11th grade. The question is this a direct variation? Is age a direct variation of what grade you're in? And so if we look at our constant rate of change, we're going up 2 each time and up 2 each time here. So in theory, that sounds really good. But if we work backwards to see if we hit 0, we're going to see that we have a problem. So we can follow this same pattern but subtracting, and in 1st grade that means we're turning 7. And then we need to subtract 1 more to get to 0 grade, which would I guess be kindergarten. But that's our 0, so minus 1 and minus 1, we do not hit the point 0, 0, which means this is not a direct variation or not proportional. The other way to tell is that you could take each one of these and count them as a fraction. And so 9/3 gives us 3 if we do that division. But 11 divided by 5 is definitely not 3. And 13 divided by 7, definitely even a different number. So each of these, if we reduce them down, they do not reduce down to the same thing. Therefore, not proportional. And then just as a final reminder for the extra kinds of questions with the cross multiplying, we've got the problems that we did yesterday. So they look like find x when y equals 12, if x equals 2, when y equals 3. So remember, I like to have you, it doesn't really matter, but just for me, I like to put the y over the x to help me remember my slope stuff. And I'm going to write the bottom fraction that's complete as a fraction, putting y over x. So that's 3 over 2. And then we're going to do the same thing to this row, y being 12 and x being x, because that's what we're trying to figure out. Okay, and we can cross multiply if we want to. So 2 times 12 is 24, divided by 3 is 8. Or we can notice that 3 goes into 12. 3 times 4 is 12. And so we have to times 4 on the bottom. 2 times 4 is also 8. Okay, so hopefully that's a good review. Try the practice test and let me know if you have any questions.